Very good morning students. In today's class we are going to learn about the linear filtering method. So the second method I am going to teach, which is the overlap sieve method, and this overlap sieve method, as I told, its objective is to find the linear convolution between x of n and h of n and name the output as y of n. So what is the procedure says? So the first step it is to find capital N, M and L. So n, you know the number of samples which we are going to divide with respect to x of n, and m represents the length of h of n, and L is the block length which is having the formula as 2 power of m or n plus m minus 1. As I told, you can use the formula 2 power of m provided capital N value is not given. If it is given, you can use the formula n plus m minus 1 to find the block length, or sometimes they will give it in the problem statement itself. The block, assume the block length to be 5 6, or assume do 5-point circular convolution or 6-point circular convolution, then it represents the block length L. Okay, and the second step is that you need to frame the sequences h dash of n by taking the entire sequence h of n and adding zeros at the end, so that the entire length becomes the block length capital N. And in the same way you need to do for x1 dash of n, x2 dash of n. So how to frame x1 dash of n is, first to divide the entire x of n into x1, x2 and x3 based on the capital N. Then you take down x1 of n, and to the left hand side you need to add zeros. So how many zeros you need to add is m minus 1 zeros. Why? Because the entire length has to be capital L. As we know, L is equal to n plus m minus 1. So we are adding m minus 1 zeros at the initial stage, that is at the left hand side. Okay, so this becomes x1 dash of n. In the same way you can do it for x2 dash of n, where the difference is for x2 dash of n, take down the x2 of n samples. Along with that, to the left you need to add m minus 1 number of data from the past x1 dash of n. Okay, that is from the past x1 of n or from x1 dash of n. So now the entire length becomes L. So this is how to frame x1 dash of n, x2 dash of n. And in the same way for the x3 dash of n, what you have to do is write first x3 dash of x3 of n values, then in the front, that is in the left hand side, add m minus 1 number of data from x2 of n, so that the entire length becomes capital L. So what is the next step is, you need to find out the circular convolution between x1 dash of n and h dash of n and name it as y1 dash of n. And similarly y2 dash of n is obtained by taking circular convolution between x2 dash of n and h dash of n. The same way you can do it for y3 dash of n, y4 dash of n based on the x of n data. So step 4 is, you need to find the m minus 1 samples from a y1 dash of n, y2 dash of n, and you need to remove this m minus 1 samples to get y1 of n, y2 of n, y3 of n and so on. So later the final linear convolution output, it is obtained just if you are going to concatenate y1, y2, y3 and so on to get the entire y of n. And we know the range of small n is going to be 0 to n minus 1. So this is the procedure for doing the overlap sieve method. So let us solve a problem based on overlap sieve method. So the procedure is, let us see the problem statement. Consider a FIR filter with impulse response h of n is given as 3, 2, 1, 1. If the input x of n is 1, 2, 3, 3, 2, 1, minus 1, minus 5 and so on, find the output y of n using overlap sieve method, assuming the length of the block is 9. Okay, so what are the data given in the problem statement is, x of n is given, h of n is given, and you need to find the output y of n using overlap sieve method, and block length is given as 9. So block length is 9 means it represents capital L. So let us solve the problem. So first step, as you know, you need to calculate what is capital L, n and m. So from the given data, L is equal to 9 and m is equal to the length of h of n, which is 4. Now you can calculate capital N using the formula L is equal to n plus m minus 1. So by solving it, we are getting n is equal to 6. So using this 6, I am going to divide the x of n as 6 samples, and I am going to name it as x1 of n, x2 of n and x3 of n. Okay. So next step, as I told, you need to find the circular convolution between x1 dash of n and h dash of n, okay, to get y1 dash of n. So once you framed x1 dash of n, you perform the circular 9-point circular convolution between h dash of n and x1 dash of n as listed as a table here. So the output is y1 dash of n. So from y1 dash of n, you need to calculate y1 of n by removing the m minus 1 values from y1 dash of n. So as we have added 3 zeros, you need to remove the first 3 samples. Why? Because with the zeros only we are calculated, and since it is of no value, no weightage for the final output, I am just removing that. That is 3 zeros we have added for the input x1. So with that only we have calculated. So remove those 3 values and write down the remaining samples, which is named as y1 of n. So y1 of n, we are getting it as 3, 8, 14, 18, 17 and 13. So the next step, as I told, is you need to calculate y2 dash of n, which is obtained by taking 9-point circular convolution between x2 dash of n and h dash of n. Okay, so do the circular convolution procedure and get the output as y2 dash of n, which is 18, 17, 9, 4, minus 5, minus 13, 6, 23 and 11. Again, even here you need to remove the first 3 samples. Why? Because already the first 3 samples, it has been calculated for y1 dash of n. So remove this and you start with 4, minus 5, minus 13, 6, 23 and 11. So in this way you have to calculate y2 of n. In the similar way you can do it for y3 dash of n and remove the first 3 samples, and the output is y3 of n is starting from 15, 9, 7, 9, 4, 3. So the last step is just you have to coordinate y1 of n, comma y2 of n, comma y3 of n. So whatever the output you got, just you need to coordinate and you have to write it as a whole sequence for y of n. So y1 of n, we know we got y1 of n as 3, 8, 14, 18. See, it is written here 3, 8, 14, 18, 17 and 13. And for y2 of n, it is starting from 4, minus 5, 13, 6, 23, 11, and y3 of n is 15, 9, 7, 9, 4 and 3. So this is the final output, linear convoluted output y of n. Again, this particular output you can cross verify by doing the normal linear convolution procedure. You can verify it. Okay, so one thing what I want to remind you is using the linear convolution methods, that is both overlap and overlap save method, you will be getting the same solution. Only thing is the procedure differs and output will remain the same. And even this output you can cross verify with the normal linear convolution procedure. Okay, and these are the 2 methods what you have learned for the linear convolution. Okay, it is also known as linear filtering methods. Okay, thank you. Thanks for watching. Let us continue in the next class. Thank you.